Given this curve, the equation, but we've got P and Q as unknowns, and we're told that it passes through 3.5, it has two vertical asymptotes, x equals 2 and x equals minus 3. Now what that means is the function will not be defined at those points, and it's because of the denominator. So we've got an x plus 3 in here. When x is equal to minus 3, we're going to get 0. So explain how we can deduce that q is equal to 4. Well, it must be that 2x minus q is equal to 0 when x equals 2. That means 4 minus q is equal to 0, so q is 4. We're then asked to show that p is equal to 15. I'll do that over here. Okay, so that's in my numerator. I've got this point, 3.5, so I can just sub that in. A half will equal p minus 3 times 3, so 9, divided by 2 times 3, that's 6, minus my 4 to give me 2. And then x plus 3 is going to be 6. There we go. So I can multiply through by 12. 6 is p minus 9. So p is 15 as required. And I can now even write down my function as y equals 15 minus 3x all over 2x minus 4 times x plus 3. This is going to be useful for the next part. So we're now given a sketch of part of the curve, 3, and some other point here where it hits the x-axis, and we're asked to find the exact area. Okay, now first of all, we need to find out that little, what the x value is, where that purple dot is. And it's going to be when y is equal to 0, which means it's going to be when the numerator is equal to 0. You can always set it equal to 0 and times through by the bottom. You'll end up with 15 minus 3x equaling 0. So x is going to be 5. Therefore, I'm doing the integral from 3 to 5 of this function. Now it's a fraction. We don't clearly have the derivative of the bottom equaling the top. It's not one of those f dash x over f of x ones, because I've got 2x squared. That will become 4x. It's not really like a substitution. I'm just talking about the sorts of things you'll be thinking about. It's going to be partial fractions. Okay, it's nicely factorized. We can split it up. So I'll do that over here. 15 minus 3x divided by 2x minus 4x plus 3. I'm going to let that be identical to a over 2x minus 4 plus b over x plus 3. Multiply through by this denominator, so 15 minus 3x is identical to a x plus 3 plus b 2x minus 4. Again, let's sub some values in. X equals minus 3. That's going to give me 15 minus minus 9, or 24, is going to equal b times minus 6 minus 4 is going to be minus 10, which means b is minus 2.4. Okay, normally expect to get a whole number. When I got this, I was like, oh, have I done it? I double checked it, but that is the answer. And then x equal to 2, because that's what's going to make this 0. 15 minus 6, that gives 9, is equal to 5a. So a is 9 over 5. To divide by 5, you can divide by 10, the times by 2, you get 1.8 for a. So back to our integral then. We've got 1.8 over 2x minus 4 minus b, which was 2.4, over x plus 3. These both become ln. So the first one, I'll get ln modulus Just realized I need a bit more space, so let me bring it down. Okay, just bearing in mind what we're trying to get, a ln 2 plus b ln 3. So ln 2x minus 4. Now when I differentiate that back, I'd get 1 over 2x minus 4, and I would times by the derivative of the inside, I'd times by 2. So here I need to divide by 2, so I'm going to get 0.9 because it's 1.8 divided by 2. If you check back and differentiate, you'll get the same thing. This one's a little bit easier, just 2.4 ln x plus 3. And let's sub these values in. So 0.9 times ln 6 minus 2.4 ln 8 minus 0.9 ln 2 minus 2.4 ln 6. Okay, now I've got a ln 8. Remember, you can't really stick this in your calculator because as soon as you put it in your calculator, you just get a decimal. So we've got to think, how can we get ln 2 and how can we get ln 3? Well, 8 is actually 2 cubed. So I can write it as 2.4 ln 2 cubed. In my next step, I'll bring that 3 down. I've got a ln 2 here, and I'm going to get plus 2.4 ln 6. So I'm going to add these two together. That will give me 3.3 ln 6. I'm going to have to do something with that in a minute because it's not ln 2 or 3. And then I'll be bringing the 3 down and timesing it by 2.4, which actually gives me 7.2. Minusing the 0.9 gives me minus 8.1 ln 2. My only other step is to separate that ln 6 into its ln 2 times 3, which means it's actually ln 2 plus ln 3. I'm just using my rules of logs in different places here. Hopefully you're happy with that. So 3.3 ln 2 plus 3.3 ln 3 minus 8.1 ln 2. And therefore I've got 3.3 ln 3. Then it's 3.3 minus 8.1. That actually becomes 4 minus 4.8 ln 2. And that is our exact answer. So, okay, some non-calculator work at the very end to get it. Good question. Well done.